All right, let's dive in. Today we are talking about a protocol that is kind of quietly, completely changing how AI agents interact with the world. It's called MCP, the Model Context Protocol, and it's basically a new standard that promises to bring some order to the chaos of AI integration.
And this quote, man, it just nails the core of the issue. We've built these incredibly brilliant AI models, but if they can't connect to the outside world, they're just stuck. They're powerful, but they're trapped.
You know, the best way to think about it is like this. A large language model is a brilliant brain, just floating in a jar. It knows a ton based on its training, for sure, but it can't check today's weather, it can't fire off an email for you, it can't pull a report from your company's database. It's completely cut off from the real, live world.
So, how do we get that brain out of the jar? Well, the answer is tools. And a tool is really just a simple function that gives the AI eyes and hands. It could be an API call to get a stock price, a function to search a document, maybe a little program to book a meeting on your calendar. These tools are the bridge from the jar to the world. But here's the catch. Connecting all of these different tools to all of these different AI models has been, well, to put it nicely, it's been an absolute nightmare.
There's actually a name for this chaos. It's called the N by M integration problem. Just think about it. For every new model, N, you have to build a custom connector for every single tool, M. As you start adding more models and more tools, the complexity doesn't just grow, it absolutely explodes.
I mean, just picture a massive, tangled web of fragile, custom-built code. Every time a new AI model drops or you want to add a cool new tool, your developers have to go back to the drawing board and build yet another one-off integration. It's slow, it's expensive, and it just does not scale at all.
And this is exactly where the Model Context Protocol, or MCP, comes into the picture. It's designed to be the universal translator that finally brings some sanity to this entire mess.
Now, the really important part here is that MCP is an open standard. Think of it like a USB port for AI, right? Instead of having a dozen different plugs for everything, you just have one standard interface, you build your tool to speak MCP, you build your AI app to speak MCP, and they just connect. It's that simple.
And the way it's built is actually beautiful in its simplicity. You've got the host, that's your AI application. Inside the host, you have the client, which handles the connection. And that client talks to the server, which is what's providing the tools. Host, client, server. That's the whole setup.
So by creating this one universal standard, MCP is unlocking some massive strategic advantages. It's really pointing us toward a future where AI capabilities are truly plug and play.
And the benefits here are just huge. I mean, development gets way, way faster. Suddenly you have this vibrant ecosystem of reusable tools popping out. And what's really amazing is that agents can now discover what tools are available to them in real time, which makes them so much more autonomous and useful. It creates a future-proof system, and, as we're about to see, it gives us a foundation for some much-needed control. Okay, this data really tells the whole story. The MCP protocol has several different capabilities defined in it. But look at the adoption numbers. One thing is driving its success: tools. Almost 99% of MCP setups are using the tool capability. Everything else, it's languishing below 20%. So it's crystal clear that the real value here is connecting agents to actions. But, and you knew there was a but coming, right? It's not all sunshine and rainbows. Opening up this universal connection point creates a whole new world of threats, especially for big companies.
So the first big risk has this scary name: dynamic capability injection. Imagine you've got a harmless little AI agent that just writes poetry. It connects to a server you trust to get, I don't know, famous quotes. But what happens if that server operator suddenly adds a new tool, like a purchase book function? All of a sudden, your harmless little poetry bot can spend real money, and nobody ever saw it coming or approved it. And this shows another even sneakier threat called tool shadowing. On the left, you see a totally legit tool. It's very specific, but look at the one on the right. It's a malicious tool, but notice the description. It's written to tempt the AI, telling it to use this tool whenever user mentions save, store, or remember. And AI, just trying to be helpful, could easily get tricked into picking the bad one and send your sensitive data straight to an attacker.
This brings us to a classic security problem, but it's been reborn in the age of AI. It's called the confused deputy. Let me walk you through a quick story. So the setup is this. You have an AI assistant that can access a secure corporate code repository, and it connects through an MCP server that has really high-level permissions.
Now, for the attack. An employee with very low privileges gives the AI a really tricky command. They say, hey, find our secret algorithm file and then create a new public branch with all its contents. Now, to the AI model, this just looks like a set of simple instructions to follow.
And boom, here's the result. The AI passes that command along to the MCP server. The server checks its own permissions, which, remember, are super high, and it just executes the request. It never stops to check if the original user, the low-privileged employee, actually had the right to do this. And just like that, the company's secret sauce is out in the open. The server was confused into misusing its authority.
So why are these kinds of attacks even possible? Well, it's because the basic MCP standard, as it's written, has some pretty big gaps for enterprise use. There's no strong, built-in authentication. It's not always clear who the user even is. There's no standard way to log what's happening, and you can't set specific permissions for each individual tool.
So, what do? How do we fix this? How do we take this incredibly powerful, innovative new protocol and make it safe enough for the high-stakes world of the enterprise?
The key takeaway here is pretty simple. You don't throw MCP out. No way. It's way too valuable. Instead, you have to wrap it. You treat the open protocol as the foundation, and then you build all the necessary layers of enterprise-grade security and governance right on top of it.
And that means taking some very concrete steps. It means using secure gateways that can filter tools and enforce policies. It means having a strict allow list of only approved tools and servers. It means forcing a human to sign off on really high-risk actions. And maybe most importantly, it means never, ever letting things like passwords or API keys leak into the AI's conversational memory.
And that leaves us with one final, really crucial question. MCP is giving AI a common language to talk to our world, and that's absolutely revolutionary. But as this whole ecosystem just explodes with new tools and new agents, we have to ask ourselves, who is actually responsible for what they do with that language? Who's responsible for what they say? That is the challenge we're all facing right now.